Hello, welcome. In last week's stream, we managed to get our AKS cluster auto scaling, and we set up a bunch of configuration around the OS disks, the maximum number of pods, and the minimum and maximum number of nodes we want in our cluster. And this week, we're going to take that a bit further and mess around with node pools and try to make our cluster highly available while still having really good performance. So that's our task for today. We're going to get right into it. So let's get started. So I had a bunch of things I wanted to talk about last week, so that I didn't get time to do. So we're going to jump right into that now. First of all, I was looking at, so if you remember from last week, this is the configuration we need so far to set up a Kubernetes cluster. And we're not using these config settings yet. We will do soon, but we are using these ones. So these ones are just setting up the basic environment, and these are config settings for our Kubernetes cluster itself. We've managed to set up maintenance hours for when we want our cluster to get upgraded and when we want to schedule maintenance. And then we've got our this should probably go up here, our node pool settings. So things like what VMs do we want, when you want to scale down, what do you want to do with the nodes, the OS disk type, the disk size, the minimum and maximum number of nodes we want to have in our cluster when we have auto scaling enabled, and the number of nodes we want to upgrade at the same time, and the maximum number of pods as well on a particular node. So there's a bunch of settings there, and then we've also got a couple of settings down here around what SKU do we want our Kubernetes cluster to use, and do we want to auto upgrade our Kubernetes cluster. And I've set it to stable as well. So we have similar set of settings over here. I'm just going to move that up as well for production. So in production, we have some extra nodes, and I was looking at the VM sizes over the last few days, and I've spent a bunch of time looking at what the best node sizes are, and I've settled on this one. And I'll just kind of briefly talk through my reasoning on that. So node sizing is really a complicated subject in Azure. There is a thing called Azure Compute Units. And if you go to this giant list in the documentation, you can see a list of all the nodes, node types or virtual machine types that you can buy, and their relative performance scores. So I chose this D2 ADS model, and if I remove the 2 represents the number of CPU cores it has. I should DADS. I should have came up with something. I'm not sure why it's not. It looks like those machines are not on this list. Interestingly enough, the ones that I chose. So there's really two choices as far as I'm concerned. I would like to use the latest CPUs, and the latest CPUs involve using the V5 variants and you can choose AMD or Intel. And these guys, DDV5 and DDSV5, are the Intel Xeon variants. And then these other two over here, oh, what's happening? I'm getting really low FPS at the moment for some reason. Something happened on my machine to cause that. Whatever it was is stopped now. So we'll just carry on. These guys over here are the AMD EPYC variants over here, the latest CPU processors that Azure offers. and I just chose the cheapest one here. Interestingly, the AMD VMs are seem to be a bit cheaper as compared to the Intel ones, even though they have 2 CPUs and 8 gigs of memory, both of the smallest instance sizes here. So I thought I'd go with those for production to begin with, although what Azure recommends is that you have a minimum of 4 CPU cores for the system nodes, and we'll come on to what we're talking about when we talk about system nodes in a second. So I went with that, and I thought I'd check that in, but it's not. Why is this not updating? I have no changes for some reason. Production. Oh, weird. I have 2 changes here, but Visual Studio is telling me nothing. So I'm just going to quickly. The build must be stopped before it can be closed. Okay. I'm going to quickly restart Visual Studio there. I don't know what's gone wrong there, but let's restart that really quick. So that's CPU sizes or VM sizes talked about. We also briefly looked at last week the OS we can choose, and we're using Linux because I think that's the main thing you'd use if you're using a Kubernetes. But you can also choose the OS, and then we did talk about whether we should use CBL, Mariner, or Ubuntu. This is CBL Mariner is like an Azure specific OS type, but I thought I'd just be specific and be explicit and set Ubuntu here. Then I also wanted to set some node labels on each node. So I'm going to stick some code in here that I put together. And what this does is on each node, it sets up a bunch of labels. So this is going to say the name of my application, ummit.com/application or /environment for these labels. And then I'm just going to pass in the configuration items for those. So that just gives me each node a bit of extra information about what environment it's in and what application it's for. This naming convention is really based on really copying the Kubernetes node labels, which all start with kubernetes.io/ and then the name of the key and then the value. So just copying that there. And that's really it so far. So I'm just going to check that in. So add VM M size. So we're just going to add those, commit that, add node labels, and commit that as well. So that's the kind of leftover stuff from last week. This week, we're going to have a look at high availability and how we achieve that using Azure AKS. And the recommendations are that you use a bunch of different node pools, and a node pool is like a group of a grouping of a bunch of nodes. This particular node pool is using a system node pool type, and system node pool type just means that the Kubernetes containers are run on this node. You can also select user, and that means that no Kubernetes nodes are going to be run on that node. The recommendation is that you use 3 up to in production, a minimum of 2 and a recommended 3 nodes, system nodes, and then a bunch of user nodes. So that's what we're going to do today. So I'm just going to cut this out, this bit of code here, and we're going to go up here and we're going to create node pool profiles, list of managed cluster agent pool profile args. Bit of a mouthful, and we're just going to stick that one in there for now, and this then becomes this guy, and we are now going to take this, and we'll have to create a bunch of new configuration items. And the way we're going to set up our configuration is something like this. So I'm going to take this, all of these settings to do with our node here, and move them down here. And we're actually going to have two sets of node pools. So the first one is our system node pool, and these are all the settings related to that. So all the settings we had before, except I just prefixed them with system nodes. And then we have our user nodes, and these are the nodes where we're going to have our actual applications running. And then these have all the same settings again. So we're going to be able to scale them independently and configure them independently as well. And then we also need to set up a new setting called availability zones, and we'll talk about that in a second. And this is going to be an array of string, and we're going to do the same for our user nodes as well. So they're going to have availability zones, and an availability zone in Azure is just an area in the data center which acts as one. So if a group or an availability zone goes down, if you still have nodes in a different availability zone, your application can still continue to run. So it's a kind of a failover area that you can use to ensure that your cluster is still available. And what we're going to do is we're going to have nodes in availability zone 1, 2, and 3, so that they're spread out. And then if one of these availability zones goes down, we lose 1/3 of our nodes, and hopefully these other two nodes, they will scale themselves up, and we'll get back to where we were in terms of the number of nodes we need. For our system nodes, we're not gonna run any application code on our system nodes. So this is the development configuration. I'm only gonna have one node here, and I'm just gonna set the minimum and maximum to 1. And we'll have our availability zones there. For our development cluster, again, I'm only gonna have one node. But we'll try 3. And we'll have one node in each availability zone for now. And max pool, I think I've duplicated that setting. That's better. So we're gonna now configure this in our configuration, and we are going to, what did I call the prefix? System nodes. And what I'll do is I will take OS disk type scale set policy. These two settings are to do with our Kubernetes cluster. I'm going to move them up here to go with the maintenance slots. We'll stick them here. And then these settings we want to duplicate for our system node pool and our user node pool. And I'll just paste that into a notepad instance for now. And we'll rename this to system nodes, system nodes, system nodes, system nodes, system nodes. and one more. And we'll take these other settings over here and we'll go down here, and these are going to be our user nodes. And we'll take those and shove those in there. It's a bit of duplication here, so we might, but some of these settings may end up being different. We'll come and refactor this later if we need to. So I'm going to take the same thing here and just kind of rejig this a little bit, and we'll take the VM size, not that size, we'll take these settings here, the skew and the tier, and we'll move those up here, and we'll rename these to, we'll take a copy of these and we'll call these system nodes. And of course we'll have to rename these also. And once we have that, we'll do the same for our we'll take these actually, and we'll do the same for our user node pool down here. User nodes. Take that text. And once we're finished copying and pasting here, we can get started on doing some actual work. And we also need to do the same here. But I'll leave the test class till later. I'll do that offline. Just unload that for now, so that we can get going quicker. And then down here, everything in the node pool configuration settings is broken. So we need to come up here and add system nodes to all of these settings. And what else do we have? This one, and this one, and this one, and that. I think that's it. Var system nodes pool. Cool. And then we're going to add that to our collection. In fact, we can just add it directly and do that. Cool. We have our system node pool. Why is this complaining? Can be simplified. How can this be simplified? Hello? Oh, okay. Fine. And we need a comma at the end for starcop to be happy. All right. So we have our system node pool now, and we are going to add the configuration setting for our availability zone to it. So we're going to go over here and add a list of int, and we're going to call it Kubernetes system nodes availability zones. And we're going to go up here and add that also here to our and this dot get collection, integer collection, and the key is this name of wrap this to the next line. The minimum is 1, or the minimum is 0, and we'll come on to why in a second, and the maximum is 3. So at the moment, Azure regions only have between some Azure regions don't support any availability zones, so there's basically only one availability zone, and other regions support up to 3. So I don't think there's any in between, so I don't think there's any with 2 availability zones. And that's an enumerable. Where have we used this before? Okay, we can use an enumerable here. Why is this complaining? Key. Oh, it's this. All right, style cop again. So now we have our availability zones. We can plug those in here. Equals, and I think you can just go configuration Kubernetes system node availability zones, and I think you need a toList here to make it happy. Availability zone for nodes must use virtual machine scale. It's a list of string, isn't it? It's not a list of integers. So although they are numbers, the availability zone values, we need to return a list of strings. So I'm just going to do a dot select toString on it on the end. So that should handle that, and that's an enumerable of type string. And do I need the toList on it? Yes, I do. Okay, so we have our availability zones now. Now the recommendation from the Azure documentation is, and we have a complaint here. Oh, culture dot invariant culture. That's important because integers, if you set toString on them in various other cultures, you may get weird values. So we use the invariant culture there. The recommendation for availability zones is that your system nodes, you use 3 availability zones here, and then you have 3 nodes. So the minimum and maximum would be 3 in production, but in development, I just want 1. We'll try 3 for this demo. And then you also don't want to set a proximity placement group. And if you remember from a previous stream, a proximity placement group here just says keep these nodes with this proximity placement group assigned to them close together, so that we get better performance, lower latency. So what we want here is so availability zones and proximity placement groups are kind of opposite ends of the spectrum. They're trying to do different things. Availability zones is trying to separate everything, separate your nodes into 3 different buckets, whereas proximity placement group is trying to bring everything together as close as possible so that we get low latency. And for our system node pool, we want to separate everything, have 1 node in each availability zone. And that's what we're going to do here. And then for our user node pool, what we're going to do is we're going to go set up the same thing here, but for our user node pool, same config setting. And we're going to call this user nodes availability zones. I'm going to copy that and stick that here. call that user nodes availability zones. And in our settings, we're also, we've got this already, and we have that set to 1, 2, 3. And we're scaling from 1 to 3 nodes, depending on how many nodes we need. And we're just gonna go to our configuration dot Kubernetes user nodes availability zones, and we're going to select that, and we're going to iterate that and create a node pool for each availability zone in our user nodes collection. So the reason we're doing that is we want to set up one node pool for each availability zone here, and we're going to set up a new proximity placement group for that as well. So actually can't be a select, I just need to for each over it. So I'm just going to adjust that there. For each in that collection, we're going to create a new proximity placement group, and we're going to call it we're going to put the zone there in the name, and then we're going to create a new node pool here, and we're going to add it to the collection. Node pool profiles.add, and we're going to add that node pool in there and fix that indentation. And now we need to switch this. Why does this not exist? Oh, I got an extra O in there. Silly me. And we'll just delete that one there. And then we're going to switch this to use availability zones equals the one we're going to use that. This one up here. And for some reason this is saying it could be nullable, but that's weird. And then we need to change all of these places where it says system nodes to user nodes. So I'm just going to do that and type that, and this is going to be user nodes. Replace that, that's good. And we're going to call this user. We also have to give our node pool a name, and we're going to call the first one system, and this one we're going to call user dash and then the availability zone. Like that. And I think that's it. So we end up with 4 node pools in total. And this one needs the proximity placement group ID. I think that's how you said it. Let me just check that. How did I do it before? Yeah. So then for each node pool here, user node pool, we're going to create a proximity placement group that forces all the nodes within that node pool to stay close together within that availability zone. And I think that's it. Let's just check my notes. So I have notes talking about the recommended VM size here, and the recommendation is you have at least 2 CPUs with 4 gigs of memory, not to use burstable like I'm doing here. The burstable, if you use the CPU too much, it gets throttled, and you don't really want that in production, but I think for a development cluster that's okay. A minimum of 2 nodes and 4 vCPUs is recommended. So yeah, you really want a a kind of a biggish cluster. So here you would go with a D4 instead of a D2, but I think that's quite overkill for a lot of situations. And that's for the system node pool, sorry. So the system node pool, you want 3 nodes ideally, and those should be with 4 CPU cores and 4 gigs, at least 4 gigs of memory. System node pools must contain at least 1 node. User node pools may contain 0 or more nodes. So let's set out our configuration for production. So we'll take all of these settings in here, delete those, not delete those, we'll keep those, but we'll separate those out for a moment while we copy them across. And in production we want 3 availability zones, 3 nodes, and we could potentially, you know, scale up to 4 or 5. So maybe we'll go up to 5 system nodes if we need them. We'll deallocate nodes for quicker instantiation of new nodes after they've been removed from the cluster. We'll go for ephemeral disk types and the VM size here. Okay, so that's the system nodes done. For our user nodes, we'll go 3 availability zones again, and we'll go 3 nodes, minimum of 1. Oh, you could do a minimum of 0 even. So if you don't have any workload, it just scales down to 0. We want ephemeral disks again, deallocate nodes, and we'll go with the same VM size. So we can delete all of this stuff over here. And for the maximum pods on the system nodes, you need a minimum of 30. So this number has to be more than 30 really, but I've gone for the max. I don't know why. We'll just dial that back to 30 again, because that's what Azure recommends. I think, and let's go back to the development version, and we're going to trial 3, 3, 3, 1 here, just so that we can see some nodes being created, and then I'll quickly delete that, and we'll go to some kind of smaller nodes and fewer nodes. So there's that, and okay. One more piece of information here. So how do we stop our user pods, user containers turning up on these system nodes? And the way we do that is we need to go back to our system node pool, and we need to add a taint. This guy here. So this just says don't schedule any user containers or pods on this node pool. So that's that. If you run a single system node pool for your AKS cluster in production environment, we recommend you use at least 3 nodes for your node pool. Yeah, we did that already. Add additional user node pools with a unique zone. Yeah, we did that. And oh yeah, if we have more than 1 node pool, we have to use the standard load balancer rather than the basic one. So we have to come down here to our Kubernetes cluster again, and we have to go to network profile, and we have to go to load balancer SKU and go with standard, which I think costs a bit more. How could we make this cheaper? We could say So in development, you may want to avoid in development. You'd go with like one system node and one user node. You could go with just system nodes as well, but I think trying to replicate production in development is a good idea. So we'll keep that separation. So we'll always go with the standards load balancer SKU. We won't try to go with the basic one if we have fewer node pools. And yeah, I think that's it for now. So let's see if that works. So we go over here, and I actually tore down my stack earlier on. We'll fire that off, and in the meantime I can get my test configuration file for unit tests working again and building again after all the changes we made to the configuration file. We'll just let that whir away in the background. So I want to, how do I do this? I want these two settings up here with my, where's the maintenance settings? I want these maintenance settings at the top, and then maximum nodes all the way down to VM size. I want to stick those and put system nodes here. And we'll copy and paste that and add user nodes. Cool. I think that, I've got the availability zone settings. Let's see how this is going so far. It's creating. This was enumerable string. Kubernetes system nodes availability zones. And we want the same for our user nodes. We're going to create some more node pools in a moment. We'll just make sure that this test still works. This test just make sure that all our Azure resources have tags on them. We'll go down here and we have an error. Obtaining authorization token from the Azure CLI. Error waiting for the Azure CLI. We have a new version of Pulumi as well. I'll just AZ login here. And just log in off screen, and we're back. And can we try to Pulumi up again? And we're also running our unit test here. Now, one thing about our unit test is that it does not look for tags in the Azure Active Directory resources. So the way you specify tags in Azure Active Directory resources, like the application, the service principal, and so on, is a bit different. It's a list of string rather than a dictionary of string. So we should probably write a separate unit test for that. So this should be all Azure resources have tags async, and then we'll write another test to make sure that all Azure Active Directory resources have tags. This failed. Why did that fail? Not really sure why. Value cannot be null. Parameter source. We'll need to debug this test, I think. See how this is going. So we got some problems. Has a problem. Agent profile's name does not match expression. Kubernetes North Europe development. So if we go back to our stack, I think we messed up the node pool names. So the name of our node pool what's this complaining about? Managed cluster resource. Agent profiles one name does not match expression. Oh, we're not allowed to have dashes in the name. That's what that is. Remove the dash there from our user node pool. Try again. Pulumi does update their stuff quite often. So this morning there was no update and now there is. Very quick. So we'll let that run, and in the meantime we'll look at running, writing a new test for our this is going to be called all Azure Active Directory resources have tags async. So what this is going to do, create our stack and check each resource for get tags. So we had a function here called get tags, and I'm going to write another one called get Azure Active Directory tags, and this one we'll rename it to Azure tags. And what this is going to do is going to return an immutable list of string, and it gets the property name is still tags on these identity resources, and they are of type input list of string. Tags property type. So we're going to try and get the tags out. And we'll get Azure Active Directory tags. We'll try to output utilities, get value. If the tags are not null, the first tag is the application, the environment, and the location. Whoops, that should be 0, 1, and 2. And let's see what this is doing. Still working. So the first one is going to be configuration. What did I do here? Tag name.application. And how did I set up the tags? Can't remember. It was in here. and key equals. So I would used an equal sign as a separator. So we'll just carry on with that, and we'll go equals, and the application name is test app. We'll stick that in there, and we'll do the same thing for the environment. And the environment is test, and the location must equal location North Europe or Canada Central, because I've set up 2 locations here. And I think that's it for this test. I don't think I need any of these container settings, so I'm just going to remove those from here and my previous test. I think that's all I needed. Common location, I don't even need that, do I? I think I do. Let's run those tests. What's this doing? Just hanging around a bit. My machine's revving up. It's my work machine that I'm using, and it's a Dell. It does like to take off sometimes. I'm not sure this is doing anything. I might just cancel it. Oh, I'm just going to try that again. And in the meantime, we can check this. What is this doing? Come on. Just thinking about it. It's taking quite a long time to build. Come on, Visual Studio. Don't be so slow today. We do need to add some more node pools. So next we're going to have a look at creating some spot node pools. And a spot virtual machine instance in Azure is, so Azure sometimes has extra virtual machines hanging around that nobody's bought. So you can get them at a very cheap price. Well, not really very cheap, but slightly cheaper. And you can use them in your node pool. However, the downside is that Azure can go and yank them away from you at any point. So they're not really very good for continuous workloads like web servers and things like that, but they are good for batch processing. So if you have some sort of while loop that runs and runs a batch process every now and then, you can use it for that. So we're going to set that up as well and see how that goes. This is not working at all, so I'm just going to cancel this build. I think the builds are interfering with each other. Maybe that's why this is not actually working. It's probably a bad idea to try to run them at the same time. Now my machine's taking off again. And see what happens here. What it's going to create for us. We should probably, because it did run last time, so some resources must have been created for us. Come on. And if we go to our dashboard and we refresh this, we've got no resources created yet. .NET build completed successfully. It needs to create all of the resources. So let's just check proximity placement group 1, 2, and 3. That's good. Where's our node pools? I guess they don't show them in here. Network watcher, service principal, subnet. Is our managed cluster, maintenance configuration. So it's created some of those resources. Let's refresh this. I'm not sure why I'm not seeing any resources here. Am I looking in the right directory? I do have a couple different ones. Oh, now we've got some resources. So we can see in here what's going to pop up in a moment. We've got an error, managed cluster error. We'll see what that is in a second. Insufficient subnet size, pre-allocate IPs 846, exceeds IPs available 507. Okay, so the CIDR that we are using, 23, is not big enough. Whoops, I clicked the wrong button there. So we do need to come back and revisit some of the settings that I'm using for our network, because I'm not entirely happy that I've got them all right. I'm not an expert when it comes to virtual networks and things like that. I think I'm going to widen this to 16, just giving all of the IP addresses of a really wide range of IP addresses to this subnet, because at the moment we only have one subnet in our virtual network. So that should now be enough to create our resources. And I'll also just check in some of our changes. Add high availability node pools, and that's all of those changes there. And this one here as well. And this change here, we haven't yet had the chance to run our test, and we'll do that in a moment. So the documentation so far that I have gone through is pretty much these how-to guides in the Azure AKS docs. I've gone through the whole of cluster operations, configuring private clusters. I have made notes on that. We're going to go through that soon. I haven't done security and authentication yet, so that's a big thing. Configuring networking is the next piece that I'm going to have a look at and make sure we get that networking correct and ingress sorted out. We're looking at configuring core DNS, so we could set up our DNS with Cloudflare so that our DNS is a bit faster. And there's a few other things like monitoring and logging we need to do. We're not going to use Windows Server containers, so we can skip that section. We can skip Open Service Mesh because I think that's kind of out of scope, although we may want to configure Azure Monitor, so we'll look at that. We can skip most of develop and run applications. We're not going to use Bridge, OpenFAS, GPUs, WordPress, API management, Dapper, or GitOps. Well, we are kind of doing GitOps because we're using GitHub. That's where our stuff is located. And then we'll have a look at some of this DevOps stuff. And that's it. I think the main things left are making our cluster private so that it's not available to the public to see. Super important for security in production. And security and authentication is quite a big subject. We'll have a look at that and see if we can make some improvements to our nodes and our cluster. We're already doing some things here. So if you go back to our code, we have not set up any SSH settings for our nodes. That is an option. So I think you can go in here and SSH. There's some settings here somewhere. Linux profile, private link resources. Not really sure where it was now. API server access profile, I think it was. And was it this one? Nope, that's not it. It was in there somewhere. Maybe it's one of these other settings. So we're not going to do that just because we don't need to. I think it's just you're opening yourself up to for an insecure environment if you do that. It's not necessarily. I think if you're going to use Pulumi, this is one of the advantages from a security standpoint, because you can completely lock down your cluster but still make changes to it, because in Pulumi you can set up deployments, services, ingress, all in C# code. So that's all in one repo. You're setting up the cluster and configuring it and adding apps to it, all in one code base. So super interesting there, and hopefully very secure. This seems to have stalled again. I'm not sure what's going on. What did I change here? Oh, that's my test that I haven't ran yet. It's still thinking. It's maybe something to do with Visual Studio locking up files, possibly. So I'm just going to restart Visual Studio as well. And yep, I think I was right. Was I right? Yes, I was right. It's working now. So if you have that problem while you're developing, just watch out for that. And maybe we can look at our spot node pools in the meantime while we wait. So we've already added our user node pool and our system node pool. So a lot of this code seems a bit duplicated, so I might come back and refactor some of this to see if we can do it. We can reduce the duplication here. So Ajmal says, I want to create private AKS cluster, and this requires DNS resolution, Kube API server, FQDN with IP address, which generally a separate step. How can we achieve this? So this is actually something I'm going to cover in the next stream. How do we create a private cluster that's not available to the public? Because if you create a cluster in Azure AKS by default, your kubelet API is available to the public, and they can have total access to it. So how can we automate this with code with Pulumi? I'm going to cover that in the next stream. So it's pretty simple. There's not much to it, but it needs a bit of explanation. I thought I'd leave this stream to just creating a bunch of node pools, and then the next one we'll talk more about security, private clusters, and securing your cluster a bit more. So okay, so we got some more problems here. The specified CIDR is conflicted with the existing subnet CIDR 16. Okay, so I think that's these settings down here, and like I said earlier, service client IPs, it must not overlap with any subnet IP ranges. Yeah, I'm not really sure what's going on here. I think I can do this. This is something I need to read more about when I get to the network section of the Azure AKS docs. Read it cover to cover and figure out what we need to do here. So I think, from what I understand about virtual networks, so we have to split up our virtual network space and divide it up like a cake, like you would take slices of a cake. So what this is doing is taking our address space here of 10.0.0.0, and we're taking quite a large slice of the cake with this /16 here. I believe, I can't remember how many numbers this uses up, but there are services out there that kind of explain this to you. So CIDR calculator, if I've used some of these in the past. I can't remember which one was good. It must be the second one, since is that gonna work? Nope. 16. So this gives you the address range. So it's using the second two numbers and giving you that /16, I believe. So various different combinations of those numbers gives you the full available address space. And if I just do, can I just use this other calculator? Yeah, CIDR notation. Yeah, so if we do say 24, you get a much smaller address space. See, it's only using the last number there, and you've got basically 254 addresses. If you do 16, you have 65,000 addresses, which is quite a large address space. So that's how much we're giving to our subnet over here. We're giving it 65,000 IP addresses, local IP addresses. And then to our Kubernetes cluster, this is the part where I need to read up a little bit more. So the service CIDR says notation IP range from which to assign service cluster IPs. It must not overlap with any subnet IP ranges. So 10.2.0.0, I think that should not overlap, because these numbers are 10.0.255.255. So 10.2.anything.anything should not overlap with this range. So I'm not sure why we're getting that error there. And then the DNS service IP, an IP address assigned to the Kubernetes DNS service, it must be within the Kubernetes service address range specified in service CIDR. So I think that needs to go change as well, actually. 2.0. Oh, okay, yeah. I see, that makes sense. So before, when this was 2 and this was 0, this was overlapping with the bigger address space I created. So now that we've swapped that over, these two are not going to be overlapping anymore. And I don't know why I used 2, I don't know why I didn't just use 1 here. And we'll do that and create this again. I think Visual Studio is conflicting again with us, so I'm just going to quickly reboot it again. Not sure why that's happening this time round. I haven't had that happen before, where Pulumi just kind of sits there. Maybe this bug fix version would fix that. I don't know. Oh, we failed. It's being used by another process. So I'm gonna quickly bring up Task Manager and kill all instances of .NET. Where's .NET? Docker .NET. Kill you. Try again. It could be something to do with running the tests. That's probably what it was. Running a test at the same time was not a clever idea for me, trying to multitask. We'll see how that goes. Come on. Oh, it worked. Now we need only the cluster itself to be created. If we go back to Azure, we should have all our resources here. So we've got 3 proximity placement groups. Let's open this up, and those have nice names, 1, 2, and 3. We have our virtual network, and so far not too much else. So nothing in our Kubernetes resource group just yet. So that's what it's creating next. This is still the old code. I changed swapped the 2 and the 0 around, so I don't know why it doesn't seem to have picked that up. Yeah, I did do that. Save, and maybe I'll do a quick rebuild. And we'll try that again. That should work now. But I really want to move on and talk about Spot node pools. So we're going to add one more node pool to the end, and that's going to be for our Spot nodes. And we're not going to have any availability zones here. And I'm not going to change the configuration values just yet. I just want to show how this works. I'm going to call it Spot. And what we're going to do here is we're going to add a couple of settings that we didn't have before. We're not going to have any proximity placement groups for the Spot nodes, because the Spot nodes can appear in any availability zone. And we're going to add scale set priority. And this just tells it that this is a Spot node and not a normal Azure node. So it's going to go and look at the Spot prices and say it's going to buy one of those virtual machines that pops up that nobody's using in Azure, hopefully for a discounted price. And then you can also determine what that price is going to be per hour. I believe this is dollars per hour. So you can say if it's less than you know, $1 per hour, I want to buy it. If it's more than $1 per hour, I don't want to. Or you can just say -1 and accept whatever Azure gives you. I think the rest of these settings will largely stay the same. So then it's just an exercise of going and changing this from user nodes to spot nodes. I'm not going to do that just yet. So I'll just kind of illustrate this point. And then a spot node also has a few problems. So the first of which is that by default, a spot node will have this label on it, so you can determine that it's a spot node. It will also have a taint on it, so no workloads, no deployments, pods will run on the spot node because of this taint. And you'll have to add a anti-affinity to your deployment to say, I'm okay with running on a spot node for this particular pod or deployment. And then once you've done that, it will run on the spot node pool. So I'm just going to comment this out for now because I haven't set up the configuration, and I'll do that offline before the next live stream. And I'm just going to talk about the settings here. So we'll have a whole new group of settings for spot nodes over here. So we'll just call that spot. There will be no availability zone, so that can be removed because all the spot nodes can turn up in any availability zones. We can set the maximum number of pods, the node count, and the minimum number of nodes. If you set it to 0, now you can't use auto scaling with spot nodes because you don't know when the spot nodes are going to turn up. So it will be interesting to see how we configure how many spot nodes we want. So the settings that I need to remove here are enable auto scaling true. That will be false, so I can remove that setting. And then the max count, that goes away. The min count also goes away, and we just end up with a count instead. I believe that's right. I need to check that about auto scaling. So there is some documentation. Let's quickly have a look at it over here. And I believe it was in cluster operations. Spot nodes, spot, create virtual nodes, use node pools, use spot node pools, and offers no high availability guarantees. Like I said earlier, it could be in any availability zone. You have to use a virtual machine scale set with the standard load balancer. We're already doing that. Limitations. You cannot change you can't change these values, scale set priority or scale set price after creation. We can if we're using Pulumi, but it's going to recreate the cluster. Oh, we have to create a toleration, not an anti-affinity. I got my Kubernetes terminology mixed up. It can't be the cluster's default node pool. It has to be a secondary node pool, so that's what we're doing. You can't upgrade node pools, so this is the problem. You can't, if your node pool's hanging around for a while, it's not going to be upgraded with the rest of the nodes. So you could get left behind, but hopefully these spot node pools, spot nodes don't hang around for too long, and when new ones come along, they pick up the version that you're using for Kubernetes. And it doesn't talk about autoscaler. Enable autoscaler. So you can do autoscaling. I was talking rubbish. It's recommended to use with node pools. Yes, that's okay. So we can do that. So we can actually go back here and we can go to 0 nodes for our spot nodes, and we'll have up to 3. And we want to scale eviction policy. This has to be delete. So we can remove this setting and go back to our Kubernetes resource. We'll just uncomment that so we get some IntelliSense. And I think this has to be scale set eviction policy delete. Scale set eviction policy dot delete, because what this is saying is when the cluster number of spot nodes needs to be downscaled, we're going to delete the nodes rather than deallocate them. I think that's you can also set the eviction policy to deallocate. Okay, so you can set it to deallocate, so maybe not. We'll keep that setting. I think I remember reading that and thinking, why are they talking about that? So we can have delete, but we're going to have delete in our development deployment, and in our production deployment we'll add the same settings, and we'll go with our v5 node type, and we'll go from 0 to 3, and we'll go with deallocate and ephemeral OS disk types. And yeah, so we end up with 3 different settings for our 3 different types of node pools. Now, it's worth noting here that for each of these availability zones, it's going to create 0 to 3 nodes here. So this is not for the 0 to 3 is not for the entire collection of user nodes. It's for each availability zone here that this is going to apply. Whereas for our system nodes, that is not the case. So 3 to 5 is the total number of nodes that will go across all availability zones here. So let's see if this is creating. It's still creating. I think that's going to take some time, and it looks like it's going to be successful this time. We'll just check Azure one last time to see what's being created, and we have a bunch of virtual machine scale sets being created. A public IP address, our Kubernetes load balancer, standard load balancer, is a bit more expensive than usual. And the VMs, I assume, are being created now, so those will take some time to pop up. So I'll leave that running, and hopefully in the next stream, what I'm going to do is I'll finalize the code for the spot nodes. This thing over here that I showed you, and I'll add the specific configuration for it. So this just all needs to be changed to spot nodes, and I'll see about reducing some of this duplication here in our code base. So I think we've got a lot of duplication here. Maybe we can reduce some of that possibly. So things that are just different about these 3 nodes is pretty much just the mode and maybe the scale set priority, max price, the name. I think that's it. Oh yeah, proximity placement group ID as well. So the rest of this code is exactly the same, and it's being duplicated. It feels a bit wrong to me, so we'll look into that. And if in the meantime, do go and like and subscribe so you can watch the next episode. And if you have any questions, you can ping me on Twitter, or at rehanse.uk, or you can go to my blog and there's a link there. You can just email me any questions or anything like that you have. Thanks for watching, everyone, and see you in the next stream where we cover security, hopefully, private nodes, private AKS clusters. And